Ever wondered how pilots navigate their way through the skies without getting lost? Welcome to the fascinating world of aviation navigation, the science dedicated to ensuring safe and efficient air travel. It's all about keeping the aircraft on the right trajectory and knowing its position in space at all times. This involves tracking coordinates, flight direction, speed, altitude, and time, calculated between specific points. There are different methods of navigation that pilots use, each suited to varying conditions of flight, distance, speed, altitude, and weather. These are observed navigation, which involves comparing landmarks with conventional signs on a map. Estimated navigation, based on various onboard instruments and calculations. Radioelectric navigation, using electronic devices of the aircraft or external means. Astronomical navigation, determining the aircraft's position using celestial bodies. Inertial navigation, based on the principle of determining acceleration on the three axes of the aircraft. And isobaric navigation, determining the aircraft's position from the difference in altitude readings at the barometric and radioelectric altimeter. Understanding these methods forms the foundation of navigation, but let's delve deeper into how they are applied in real-world scenarios. Before we can navigate, we need to understand the terrain we are navigating on. So, what's the shape of our planet? Contrary to what you might initially think, Earth is not a perfect sphere. It's an oblate spheroid, or in simpler terms, a sphere that's slightly flattened at the poles and bulging at the equator. This shape, often referred to as a geoid, is what gives us our unique landscape of mountains and valleys. But it's not just about the shape. Our planet's rotation around its axis and the existence of the north and south geographical poles play a significant role in navigation too. Picture Earth spinning, like a top, on an imaginary line called the axis. At the top and bottom of this axis, we have the north and south poles. These are crucial reference points for navigators, especially those in the air. Now that we've grasped the Earth's shape, let's move on to the imaginary lines that help us pinpoint any location on the globe. Ever heard of the terms latitude and longitude? They are more than just lines on a map. Imagine Earth as a globe, with a network of invisible lines running across its surface. These lines are latitude and longitude, a coordinate system that allows us to pinpoint any location on Earth. Latitude lines run horizontally from east to west and measure the distance north or south of the equator. Think of them as the rungs of a ladder, hence latitude. Longitude lines, on the other hand, run vertically from pole to pole and measure the distance east or west of a reference point, the Greenwich Meridian or Prime Meridian, located at the Royal Observatory in Greenwich, London. Together, these lines divide the Earth into a grid, with each point on the grid representing a unique set of coordinates. With these latitude and longitude lines, we can identify any point on Earth, a crucial aspect of navigation. We've covered a lot of ground, so let's take a moment to recap. We've delved into the world of navigation, discovering its many methods from observed navigation, which relies on comparing landmarks with map symbols, to radioelectric, astronomical, and inertial navigation, each with their unique strategies for determining an aircraft's position. We've understood the concept of isobaric navigation, which uses altitude readings from barometric and radioelectric altimeters. We've explored the geoid shape of the Earth, a complex form that closely resembles an ellipsoid, created by rotating an ellipse around its minor axis. This understanding of our planet's shape is crucial for efficient and accurate navigation. And of course, we've learned about the concept of latitude and longitude, using imaginary lines forming a grid on Earth's surface, which gives us a reliable method for specifying any location on Earth. And there you have it, the intricate world of navigation, simplified. Remember, the sky's not the limit, it's just the beginning.